Susan. And thank all of you for attending this webinar. What I will be talking about today is exploring the network of things. So I build software cost estimating models as part of my responsibilities here at Price. And so one of the things that model builders need to do is to keep on top of new and emerging technologies. So this is basically a book report on some of the research that I've done into the Internet of Things and the network of things. Oops, sorry about that. So today's agenda, start with a little introduction. Okay, why is this an interesting issue? Why do I think it's important for me to think more about it? Then I'll talk about the Internet of Things. The Internet of Things, we all are sort of familiar with the Internet of Things. We know that there's a lot more connectivity now than there was 15 years ago. And so I'll talk about the Internet of Things, what it is, give some of the various definitions for the Internet of Things. Then I'll move into the network of things. The network of things is a concept that the National Institute for Standards and Technology is trying to push forward as sort of a more formal and scientific way of thinking of instances of the Internet of Things. So I'll talk a little bit about that, and then I'll delve into some of the enabling technologies, what kinds of technologies are out there now that are being incorporated or that are making the Internet of Things and the network of things possible, and what kind of technologies are emerging to make these better and more effective and more interconnected than they are. I'll give some examples of the Internet of Things and the network of things in action. So how are these things being used now? What are some of the applications? What do we mean when we say smart cities or smart homes? Things like that. And talk about some of the future challenges and directions. So a couple quotes, and you'll see this is from 1926, and it's Tesla. When wireless is perfectly applied, the whole Earth will be converted into a huge brain, which in fact it is, all things being particles of a real and rhythmic world, and the instruments through which we shall be able to do this will be amazingly simple compared to our present telephone. A man will be able to carry it in his vest pocket. So this is not a surprising thing for us today. In 1926, it was pretty forward-looking that Tesla imagined that. This other quote, which I like a lot, ubiquitous computing, it's roughly the opposite of virtual reality, where virtual reality puts people inside a computer-generated world. Ubiquitous computing forces the computer to live out here in the real world with people. So we talk about the Internet of Things and augmented reality. Our world is being supplemented by computer capability instead of us having to delve into the computer's world. So the Internet of Things, it's a network of devices, physical devices, home appliances, vehicles, things that have embedded electronics, software, sensors, actuators, and connectivity. It enables objects to connect and exchange data. This is from Wikipedia. Forrester predicts that the market will grow from 157 billion in 2016 to 457 billion in 2020, almost 3x. Bain predicts that the business-to-business Internet of Things segment will generate more than 300 billion annually by 2020. We expect NewGens.app expects the number of interconnected things to reach 50 billion by 2020. So Internet of Things, it's an instantiation of the network of things. So the network of things is sort of a higher level. It requires, the network of things can use the Internet. A network of things can use the Internet. It could also be an Internet of Things that's applied to a different type of network. So the network of things is a broader definition in that while the Internet of Things requires the Internet, the network of things delivers the same kind of Internet of Things capability using different types of networks. So here's a couple Internet of Things definitions. The IoT defines the system of physical objects in the world that connect to Internet via sensors. The Internet Architecture Board, IoT is the network of smart objects. So a huge number of devices intelligently communicating in the presence of Internet protocols cannot be directly operated by humans, but exist as components in buildings or in the environment. The Internet of Things, this is the Internet Engineering Task Force. It's the networking of smart objects. Smart objects have some constraints, such as limited bandwidth, power, and processing ability for achieving that interoperability. IEEE communications, it's a framework of all things that have a representation in the presence of the Internet in such a way that network applications and services enabled this interaction between the physical and the virtual world in machine-to-machine computing. There's also business-to-business computing and vehicle-to-vehicle computing, and those will come up a little later in this talk. Oxford, it's the interaction of everyday objects, computing devices through the Internet that enables sending and receiving of useful data. So there's lots of different definitions, and they all pretty much say the same thing. The Internet of Things is services, is a combination of services and networks and sensors that act together in sensible ways to solve real-world problems, or not necessarily problems, to achieve real-world goals. So it's the worldwide network of intelligent objects. They're interconnected, the Internet of Things interconnected via the Internet, and excuse me, uniquely representable based on communication protocols. So 4 key technology enablers for the Internet of Things are RFID technologies for tagging things. So we need to be able to find things out there in that Internet of Things. Sensor technologies for sensing things. So we need to tag things so we know where this information is coming from. We need to have sensor technology to gather information about the environment in that location. We need to have smart technologies for thinking about things. So it's not enough that we amass this data and we put this data into a sensible format for some sort of data analysis. There also needs to be some smartness to figure out what to do with this data. If I am a smart refrigerator, I need to not only know what's in my refrigerator, but be able to communicate things to the owner of that refrigerator. If I'm a smart home, I need to see that it's dark outside and I should turn the lights on because someone is approaching the door. So there's more than just one piece of data. It's not just somebody hitting a button on their phone saying, turn on the lights, although actually that could be an instance, but it's broader than that, in that it could also be a case where the light is smart enough to know that the conditions indicate that it's time to go on. And it is basically considered sort of the 3rd generation of the World Wide Web. So we started with sort of browser-based Internet usage, and people embraced that and moved from just browser-based Internet usage to interacting through the Internet through various forms of social media. So with the Internet of Things, it's no longer just about people. People can and should be part of certain Internet of Things systems, but people are only a part of it. Now, other things, not people, are also included in this broad network of things, or Internet of Things. So the Internet of Things has 3 basic layers. So there's the perception layer. So sensors, other kinds of devices collect useful information about a specific environment. And they turn that information into a digital state. So they turn it effectively into some form of ones and zeros. And then, based on unique identification and communication, so this is depending on communication between different kinds of short-range technologies. So the perception layer is what collects and transforms the data. So the network layer is the brain. It helps, the data flows through the network. It takes the data from in its digital state and turns it into a useful state so that the application layer can use it to make decisions, to provide services